All right, so hi everyone. I guess we are live now. So welcome to Geeks for Geeks and this post analysis session of last weekly contest 186. So can someone just please confirm if I am audible and how was the entire contest and how many problem you were able to solve? Hi Abhay. Okay, I will discuss the third problem. And I personally categorize the entire contest from a medium to hard level. The first problem was very easy. The second problem, which can be solved with the help of dynamic programming, and the third problem was based on a string, and the fourth problem was a bit difficult. And for the fourth problem, you need to do some casework, and you have to come up with some mathematical formula to solve the fourth problem. So I guess we are good to start the discussion. Okay, third problem was tricky. After so many observations, wrote code, but still did not pass all the test cases. Okay, don't worry. I will discuss the fourth problem and the third, both. So let me just first share my screen. And also let me just change the template. Yeah, this one. So starting with the first problem. Qualification possibility. So RCB is a team and participating in a cricket tournament where, okay, RCB is participating in a cricket tournament where each team plays a total of 14 matches, and to qualify for the semi-final, a team must have to win at least 8 matches. And the team RCB has already completed first n matches, and you have the result of the n matches that has already completed. And the value of n is always less than the total number of game played, which is 14. And the outcome of these n matches are given in a form of a string of length n, and each character in the string represent the result of the match. W simply means the team RCB won the match, and L simply means the team RCP has lost the ith match. And the remaining matches, if any, this is simply 14 minus n. 14 minus n. N matches has played, so number of remaining matches is simply equals to 14 minus n are yet to be played, and you need to determine if there exists some strategy for RCP to win at least 8 matches to qualify for the semi-final. In other words, RCP secure at least 8 wins by the end of the tournament, considering the result of the matches already played and the matches that yet to be played. So let me just explain you this simple input. So here the value of n is equals to 8, and the string which was given to you has start with a W. That is, the first match was won by RCP, and then we have L, then W, and then the remaining matches that RCB has lost. So here in this case, total 8 matches has been played. So how many remaining matches we are left with? So this is simply n. This is simply 14 minus n. So 14 minus n. So here in this case, it is simply equals to 14 minus 8, which is equals to 6. So this simply means 6 matches are left. And let's just consider that RCB won all the 6 matches that yet to be played. So in this case, how many total wins we have? So it is simply equals to this value 6 plus count of W in string S. So count of W in string S. So let me just write in this way, count of W. And if this total value is greater than or equals to 8, then I can just simply say RCB will qualify for the semifinals, so I will return true. And otherwise, in the else case, I will return false. So else, my answer is false. A very straightforward intuition. We are left with the 14 minus n matches, and we have the result of n matches. So just simply count the number of matches which RCB has won. And here I am assuming that all the remaining matches has won by the RCB. So in total, it is simply equals to 14 minus n, which is here in this case 6 plus count of W. And if this value is greater than or equals to 8, then it is possible for RCB to qualify for the semifinal, otherwise not. So I will just simply return false. A fairly easy problem. So let me just show you the implementation. And yeah, here we have our implementation. So this is the method is possible that you have to complete. And just iterate over the given string of length n and count the number of character W, the number of wins. And then total possible win is simply equals to count of W plus 14 minus n. 14 minus n. And if this value is greater than or equals to 8, then return true, otherwise false. So this is the complete solution. Is it clear to everyone? The time complexity is linear. And the space complexity is constant. All right, Hemant, I will forward my query to the higher authorities and the team. They will definitely look into this. So just write a quick +1 if the explanation is clear to you, so that we can move to the next problem. Just a quick +1 in the chat box. Cool. Now let's just move to the second problem. So reachalize. And this was a very standard problem of a dynamic programming. So Bob is standing on the left bank of a river and Alice is on the right bank. To reach Alice, Bob must cross the river by stepping on crocodiles, forming a bridge from one bank to another, from left to right. And however, Bob must follow the certain rule to avoid being attacked by the crocodiles. There are n crocodiles in the river and are arranged in a straight line. Each crocodile is either male, which is denoted by 0, or a female, denoted by 1. A binary string of length s will be given to you, where s of I denote the type of ith crocodile. Type of crocodile at ith position. If it is 0, then male. If it is 1, then female. And the rules for stepping on them are as follows. If Bob step on a male crocodile at position I, he can jump either I plus 1 or I plus 2 to th crocodile if they exist. Or if it was a female crocodile, then he can jump only to the I plus 1th crocodile if exist. And in this way, we need to report the number of ways to reach the nth crocodile. So Bob is start on the first crocodile and must reaches to the nth crocodile to meet Alice. and we need to determine the number of ways Bob can reach to the nth crocodile. And since the answer can be very large, so we need to return this answer under modulo 10 power 9 plus 7. So a way is considered to be distinct if the sequence of indices of a crocodile is stepped on is different. Okay, this is a very standard thing. So reachalize. So how we can solve this problem? So here I need to count the number. I need to find the number of ways to reach n. To reach n, and not just only in this problem. For all such problem where you need to count the number of ways to reach n. So for all such problem, there only exist two possible solution, two possible approaches. Either you find some mathematical approach, come up with some mathematical formula, or find a recurrence relation. So mathematical formula could be anything. There might be the case when your answer is equals to n cube or log of n base something or any polynomial function, any mathematical function. And the second approach is to write a recurrence relation and count the number of ways. So recurrence relation. And for this particular problem, I want to be able to come up with any mathematical formula, and I also believe there do not exist any mathematical formula to solve this problem. So now we are left with to find the recurrence relation. So now we have n crocodile. So without losing a generality, let's just convert it into a zero-based indexing. So index 0, then index 1, index 2, index 3, index 4, and up to n minus 1. So initially the Bob is standing at here at index 0. So let's just define our states for our recurrence relation. So let's say dp of I, it will simply store the number of ways to reach I from 0. So what will be my answer? So my answer is simply equals to dp of n minus 1, the number of ways to reach to the nth crocodile. And since I have converted this into a zero-based indexing, so that's why it is n minus 1. Now for every index, I have two possibility. I need to check whether it is a male crocodile or a female crocodile. But what was my base case? So initially I am standing at 0. So dp of 0, it is simply equals to 1. There is only one way to reach from index 0 to index 0. And that one way is I am already standing at index 0. So there is only one way. Do not get confused with this thing. I don't need to count the number of steps that I have taken. I only need to count the number of ways. So I hope it is clear to everyone. Now for the remaining indexes, what I can do, if okay, let me just iterate over the remaining indices. So for I is equals to 0 and it will goes till n minus 1. Now you need to check whether the crocodile is male or female. So let's call the string as s string s of length n. So if s of I is equals to 0. Then what does it mean? This simply means the crocodile is male. So in case of male, you can either jump to crocodile I plus 1 or I plus 2. So just simply increment the dp values. So dp of I plus 1 and plus equals to dp of I. So yeah, in this way, I got one another way, that is from index I can take a jump of 1 because at index I we have a male. Then dp of I plus 1. For I plus 2, I got one way. So just simply increment it. The number of ways to reach to index I, and just simply add this value to index I plus 2. So dp of I, a very standard dp. And if it was a female crocodile, that is if s of I is equals to 1, then in this case only one possibility, from I to I plus 1. So dp of I plus 1, increment this value by dp of I, as I got one path. And finally you know the answer. So in this way you can find the result for every value of I. So is it clear to everyone? And definitely I need to check for the corner cases whether I or I plus 1 exist or not. So let me just quickly show you the implementation. And yeah, this is the method that you need to complete with the given string s. So then this is my mod, because answer can be very large. So you must have to compress this answer by taking a mod with 10 power 9 plus 7. Then here I have taken the size of the string. Then this is my dp vector, and dp vector of size n. Then dp of 0 is equals to 1. Then I iterate over all the characters, and if ith crocodile is male, then I have two possibility, I plus 1. So just simply add the value of dp of I in dp of I plus 1 and take a mod. Then similarly the same thing I am doing for I plus 2, and the same. And if it was a female crocodile, then only one possibility, from I to I plus 1. So that's why adding the value of dp of I in I plus 1 and then take a mod. Then my answer is simply equals to dp of n minus 1. And how much time will it take? This is order of n is space complexity, and order of n time complexity. Both are order of n. So just write a quick plus 1 if this solution is clear to you, so that we can quickly move to the next problem, which was very interesting and has lot of observation. So actually, Hemant, you need practice. I don't think there is any alternative. And you just need to draw few observation and convert it into a bottom up, top down to a bottom up DP. Because in a top down, we start from the function, and basically we start building the solution from the base cases. And in the bottom up, we immediately start from the base case itself. So yeah, this is the difference between a top down and the bottom up. So in a top down, when I hit the base case, that is the value of n is equals to 0, then I will start finding the answer. But in the bottom up, we immediately start from these base cases. So I don't think there is any alternative, and it is not that much difficult. Just always make sure to write the bottom up solution. So I hope this problem is clear to everyone. So shall we move to the next problem, third problem, which was really very amazing. And I personally love the third problem of the contest. One of the best problem from the recent contest. Cool. So let's just discuss the third problem. And I also discuss the approach that you might think of, and that approach would not work. So string modification. So you are given a string S consisting of n lowercase English letters, and each letter in the string can be shifted either to left or right alphabetically, and these are given in a circular order. Each character you can shift either to left or to right. That is, let's say if you have given a character B, so you can convert this B, you can change this B to A, or you can also change this B to C, and this C is a right shift and this B is a left shift, and all the alphabets are arranged in a circular order. If you apply a left shift operation, if you apply left shift on a character A, then it will be converted to Z. If you apply a right shift on character A, then it will be converted to B. If you apply a left shift on if you apply a left shift on Z, then it will be converted to Y, and right shift, then it will be converted to A. So for example, the letter G can be changed to F or H. F for a left shift and H for a right shift. And here we need to assume that the alphabets are arranged circularly, and meaning Z shifted to A on moving right and A shifted to Z on moving left. And you are also given K, the maximum number of shift that you can use in total, maximum number of shift. And for any character you can use a multiple shift, and in total the number of shift that you have used over all the n characters must be less than or equals to K. So you need to transform this S into a palindrome using at most K shift, and where among all the possible palindromes that can be formed using at most K shift, you have to find the lexicographically smallest one. So the problem has two requirements. The first requirement, we have to transform S into a palindrome, and the second requirement, we have to transform S into the lexicographically smallest palindrome. So the first one, palindrome, then the second one, lexicographically smallest. And if it is not possible to transform S into a palindrome, then we have to return an empty string. And here is the definition of lexicographically smaller. So let me just discuss this example A, B, C, D. So S is equals to A, B, C, and D. And the value of K was 2. So the very first thing, I need to convert this S into a palindromic string. So this simply means S of I, the character at index I, must be equals to the character at index n minus 1 minus I. This is the condition we need to satisfy. Let me draw some example here. So let's say the value of n is 5. So the value of n is 5. That simply means we must have a 5 characters. So A, then let's say B, and B, and let's say here we have C. So this is a palindromic string. So index 0, index 1, index 2, index 3, index 4. So 0 and then n minus 1 minus 0, which is equals to n minus 1. So we must have this character. It's the same character at index 4. And for index 1, we must have the same character at index 3. N minus 1 minus 1. So 4 minus 1, which is equals to 3. And for here, we have a 2. I will map index 2 with n minus 1, which is 4. And 4 minus I. 4 minus 2, which is equals to 2. So yeah, we must have the same character. And since we only have one character because it has a odd length. So in this way, in my palindromic string, we must have the same character at index n minus 1 minus I for every I. Cool. Now how I will convert this S into a palindromic string. So here I must have to change this A to D, or we must have to change this D to A. So how many shift do we require? So if you either change A to D or you change D to A, both will require both will require the same number of shift. A very obvious thing, because we are allowed to select the left shift or right shift both. So both will take the same number of shift. Cool. And the sky value of D, which is equals to 3. This is the fourth character. And the sky value of A, it is equals to 0. So their absolute difference, 3 minus 0, which is equals to 3. So to convert either A to D or D to A, it requires it requires 3 shift. But the number of shift that I have is 2. So that's why it won't be possible to convert the transform S into a palindromic string. So that's why here in this case the answer is an empty string. Now Now let me just explain you the second sample input. So for the second sample input, the value of k is equals to 4, and the given string, same given string, ABCD. So now let's just check if it is possible to convert this S into a palindromic string. Now the value of k is equals to 4. So the value of k is equals to 4. Now which one we select? We convert A into D or D into A. So this is very obvious that it's always it's better to convert D into A, because we need a lexicographically smallest string. So this is A and this is A. I have converted this D into A using 3 shift. Now B and C, and the number of shift that I am left with is simply equals to 1. 4 minus 3. Now we need to fix these two characters. So here we have a character B. So I will convert B into C or C into B. Definitely I will convert this C into B, because both require the same number of shift and we need the smallest lexicographically smallest string. So that's why we must have to convert it into B. So now this is B and B. So this is the lexicographically smallest palindromic string that you can generate. So I hope the problem statement is clear to you. Now just listen to my explanation. So now some of you might wondering of a very beautiful greedy idea. So let's say we have index 1, then or let me write according to a zero based indexing. So index 0, then index 1, then index 2, index 3, index 4, and index 5. So here the value of n is equals to 6. 0 to n minus 1 indices. Now the very beautiful greedy idea that comes to your mind, that I will change this S0 either to S5, or I will change this S5 to S0. And whichever character is minimum, I will select that character, because we have already discussed this thing. If you have A and if you transform this to D, then how many operations do we require? How many shift do we require? It is simply equals to 3. Or if you have D and if you want to change this to A, then also it requires 3 shift. I will use a 3 left shift. So it also then also it requires 3 shift. So which one I will select? Definitely I will select this one. You might claim that I will select this one, not this one, because we also need the smallest lexicographically smallest string. But this idea won't work every time. This idea won't work every time. So let me just give you some test case. So let's say the value of k is equals to 3. The value of k is equals to 3. And then after, let's say we have a b or Yeah, let's say we have B, then we have let's say Z, and then let's say we have C. So now the value of K is equals to 3. Value of K, let's say it is equals to 4, not 3. So I know to convert B into Z, I require two shift, or if I convert Z into B, then also I require two shift. Because first I will apply a left shift on character Z, then it will be converted to A, then from A to B. Cool. So then also it will take two shift. So now some of you might wondering that might wondering that I will convert this Z to B. So just simply change this Z to B. So B, B, and C, and now you are left with a left with the two operations. So where it is optimal to use this two operation? So now you are going to use these two operation to reduce this, but it is not the correct solution. This one is not the correct solution. Now instead of using it here, instead of using in this way, I will convert this Z to this B to Z. I will just simply transform this B to Z. So Z, C, and Z, and now I am left with the two operation. So now these two operation I will use to convert this Z to A. Now I will use these two operation to convert this Z to A. So A, C, and A. This is the expected output, and the best way to write the solution. The best way to use all the K shift. Now the value of K is equals to 0. So is it clear to everyone? So what the best greedy approach that you can use? The best greedy approach that you can use, that you can say that I will convert every S of I to either S of n minus 1 minus I, or S minus 1 minus I to S of I. So whichever I will select one which is max, which is minimum. I will select one which is minimum. But this greedy approach won't work for all the cases. This greedy approach won't work for all the cases. But let me just complete this greedy approach. So I will select minimum for every pair of S of I and S of n minus 1 minus I. For every pair I will select the minimum. And now I am left with some operation. After this, after converting it to a palindrome, now I am left with some operation. And if the value of K after converting it into a palindrome is equals to 0, this simply means you require more number of shift than K. So in that case, it won't be possible to transform S into a palindromic string. So in this case, your answer is simply equals to empty string. So just simply return empty string. But there might be the case when after converting it into a palindrome, we are left with some operation. That is value of K is equals to 0. So in this case, where do we use the K? So now some of you might claim that I will keep on decreasing the characters. So let's say the value of K is equals to 10, and the string that we have, let's say it is equals to B, and then here let's say we have a Z, and let's say then we have a C, then we have A, and then we have or instead of changing this to C, let's say we have a D and F, and then let's say we have a K. Cool. So the very first thing, I will convert this Z to B. So B, D, K, F, and B. And how many operations do we require? Two. So now we are left with 8. Now the next, now what next? Now after this, now I know these two characters are fixed. These two characters are fixed. So now I will check for the next index, that is these two character, because first I will convert this into a palindromic string, and then I will change to the lexicographically smallest. The first condition you must have to satisfy. So then I will convert this f into d. I will convert f to d. So after this, b, d, k, and d, and then here we have again b. So in the first case, I have selected these two indices, b and z. Then here these two indices, and now this k. This k is already this k is a separate individual character, because you don't have to change any other character because it has odd length. So this is a middle character which can be anything. And now I am left with 7 operation. Now I am left with a 7 operation. So now how I will use these 7 operation. So first I will try to reduce every character to a, because a is the smallest alphabet that we have. So I will perform one operation and reduce this to a, a. Now my operations have reduced by 2. So now it is equals to 5. And this is a d and d, and this is k. Cool. No, it is not 6. It is not 6. It is a 5, because here I have applied one left shift, and here also I have applied one left shift. So this is not 6. It is 5. Now I am left with the 5. So now where I will use these operation. So just simply reduce these characters, because the first character has already changed to a. So after this my new string will be a, c, k, c, and a, and the number of operation, this is simply equals to 3. Now let's just apply operation one more time. So apply operation one more time, then it will be converted to b, and the remaining characters would remain as it is. And now you have a one operation. So now you cannot use this one operation. You cannot use this one operation here, because we must have the same character. We must have the same character at position I and n minus 1 minus I. So that's why we cannot reduce it further. So let's just use this one operation for the middle character. So I will use this one operation for the middle character. So now my new string a, b, and then j, b, and a. What if we convert b to a and z to a? In that case, k value is reduced by 2. So yeah, this is the greedy solution that you might come up with, but this won't work for all the cases. This won't work for all the cases. Now let me just give you some test cases uh, for which your this greedy approach fail. So let's say the value of s is equals to h, k, and z, and let's say the value of k is equals to 10. So the very first thing that you might think that I will convert this z into h. This is z into h. So here if you convert this z into h, so h, k, and h, and how many operation we require? The sky value of z, it is simply equals to 25, and the sky value of h, it is equals to 7, if I'm not wrong. Yeah, it is 7. So how many shift do we require? So 25 minus 7, which is equals to 18. Cool. So 18 shift we required, but we only have we only have a 10 shift. We only have a 10 shift. So it won't be possible to convert this z into h using left shift. Now let's just try to convert this z using a right shift. That is, I will convert this z into a, then this a into b, then this b into c, and then up to h. So how many operations do we require in that case? So it is simply equals to 26 minus this 18. 26 minus this 18, or you can say the difference between these two characters. So 26 minus 18, which is simply equals to 8, which is equals to 8. Cool. And now I'm left with two operation. So this is equals to 8. Now where it is optimal to use these two operation? Where it is optimal to use these two operation? So if you say that it is optimal to use these two operations here, that is just simply reduce this h to g. So g, I have just applied a left shift over these two character one time. So now the value of k is equals to 2. Now the value of k is equals to 0. So now you will claim that this is the lexicographically smallest palindromic string. This is the lexicographically smallest palindromic string that we can generate. But this is not true. This is not true. From here, what is the best path? The best path is to convert h into z. So in this case, z, k, and z again. Cool. And after this, I am left with the two operation, because the same number of operation required to convert z into h. And then after, just simply reduce this z into a. Apply a left shift. Sorry, right shift. So a, k, and a. So now you are left with the zero shift. And this one is the smallest palindromic string. So this is not the best answer. This is the best answer. So is it clear to everyone, this solution? Just write a quick +1 if the approach is clear to you. What about the other participants, other people? Is it clear to you all? So now this greedy approach won't work here. So now I need to check for every character. I cannot say that it is best to convert z into h. And here is the test case. For this test case, it is best to convert h into z to get the lexicographically smallest palindrome. So let's just declare an array cost, and this array cost, we'll discuss about its size very soon. And then the second dimension would be 26. And then we all know the character at index I must be equals to the character at index n minus 1 minus I. So every character which is okay, so I can map every character I to other character n minus 1 minus I. So that's why I only need an array of size n plus 1, because there might be the case when the value of n is odd. So in this case, you have a middle index which is independent, and that middle index is not being mapped with the any character. So let's say we have n is equals to, let's say, 5. So in this case, how many indices we have? Index 0, index 1, index 2, index 3, and index 4. So that's why you only need to create an array of size n plus 1 divided by 2. And with the index 0, I will also track index 4. With index 1, I will also track index 3. And index 2 is independent. That's why I've added 1 and divided by 2. So now this is the dimension of my cost array. and what it will store. So cost of I comma j, or let's say this as c. So cost of I comma c will simply store minimum shift required required to convert, or I can say to change, s of I and s of n minus 1 minus I, because both characters must be same, into character c, and I will add the sky value of a to convert it into a character. So c plus a. Cool, because this c is an integer. So c plus a, the minimum number of shift required to change s of I and s of n minus I both into c plus a. This is the character, this character. And so how I will find this thing? So just simply iterate over all the indices, and for every character you have two possible path. Let's say I have a character a. Let's say I have a character a, and then I have a character b. And if I want to transform a into b, then what are the different possible path I have? So I have two paths. Either I apply a left shift, or I apply a right shift, because and which one requires the minimum shift? That will be my answer. So without losing a generality, I am assuming that the sky value of b is greater than sky value of a, and if a was greater than b, then just simply swap a and b. So as of now, I am assuming that character a is having sky value smaller than character b. So these a and b are the character name, not the exact character. So let me just draw some characters here. So 0, or let me write it this way: 0, 25, then 24, then 23, and so on. Then 1, 2, 3, 4, and so on. So this is character A. This is character A. Then this is character Z. Then Y. Then this is B, C, D, E, and so on. So this is in a circular manner, right? So let's say my character A is C, my character A is B, and let's say my character B is D. So I have two possible paths, right? Either I convert this D, I convert this B into D. Either I convert this B into D using this way, or I follow the circular order. This circular order. So whichever takes the minimum, that will be my answer. So for this, let's call this a distance as a d1. So d1 is equals to sky value of b minus sky value of a. These many shift you require. Or d2, this is simply equals to 26 minus this value of d1, or I can say b minus a, sky value of b minus sky value of a. And your answer is simply equals to minimum of these two value, minimum of these two paths, whichever take lesser shift. So d1 comma d2. So in this way I will find I find for every possible value of I and c. So in this way I will fill this cost matrix. And also I know the first condition that I need to satisfy is palindrome, is the condition of palindrome, that the string must be a palindrome, and the second one is lexicographically smallest. Lexicographically smallest. So that's why I will first use all the key operation to convert the string, uh, use the key operation to convert the string into a palindrome. And if we are left with some operation, then I will use those operation to convert it into a smallest palindromic string. Cool. So that's why that's why let's declare another array as per my implementation, but you might have some different implementation, but the idea will remain same. You need to check for every character. So here I will create a DP array. This could be also of size n plus 1 divided by 2, but as per my implementation I have declared this as of size n, but you can also go with n plus 1 divided by 2, this size, and initialize all the element with some bigger values. And dp of I, it simply store minimum shift minimum shift required to make s of I equals to s of n minus 1 minus I. So what is the value of this dp of I? The value of this dp of I is simply equals to cost of I and c, cost of I and c, for all the values of c, in the range from 0 to 25, because we could have any character at position I. So that's why for all the characters, so the range of this c, 0 to 25. So is this thing is clear to you? And then I will reduce my k. I will reduce my k by this value of by value of dp of I, and so that I know after the first traversal my string has been converted to a palindrome. Just write a quick plus one if up till here everything is clear to you. Cool. So after this, after the first traversal, I know my string has been converted to a palindrome. Now the next step, and if the value of k, is less than 0, then it simply means it won't be possible to convert this s into a palindrome. So just simply return an empty string. Now let's just check after this how I will use this remaining values of k. So use remaining k optimally. So now how I will use the remaining k values optimally. So how I will use the remaining k values optimally. So for this thing, I again need to iterate over the indices. So from I is equals to 0 and up to n divided by 2. or as per my implementation, what I have did, you can also go with this for loop, which I personally found more intuitive. But as per my implementation, just simply I had declared two variables, I is equals to 0 and j is equals to n minus 1. Basically, I put this variable j to the first index and variable I to the first index and the variable j to the last index. And then we all know that we have to make these two characters equal. Then I will just simply decrement j and increment I. Then again I decrement j and increment I. So in this way, I am moving this I forward and moving this j backward, decrementing j, incrementing I. Cool. So then for every index I and for every index for every index I, what for every iteration, what you can do, iterate over all the characters while value of I is less than or equals to value of j. Just iterate over all the characters. So I know the minimum number of shift that I required, to make these two characters, character at index I and j, equal is simply equals to dp of I. dp of I has simply stored the minimum number of minimum number of shift required. And so I iterate over all the characters. So for C is equals to 0 and it goes till 25. Just simply check. If cost of I comma C minus dp of I is less than or equals to k, then just simply change the character, that is s of I and s of j. S of I is equals to s of j. You can also write n minus 1 minus I, which is equals to j. So s of j and make it equals to C. So C plus A, sky value of A. This C is the ordinal number and plus A to convert this into a character. So now I have changed these two characters and then just simply decrement the value of K. So decrement the value of K by this difference. Just simply decrement the value of K by this difference and break the loop. Because let's say, let me just explain you with an example. So H, K and the same example. Cool. So H, K and Z. So first what I have did, I have computed dp value. So dp of 0, this is index 0, then this is index 1 and this is index 2. So first I have computed dp value. So what is the value of dp of 0? That is, what is the minimum operation do you require to make these two characters same? What is the minimum operation we require to make these two characters same? So this is nothing but simply 8 operation. 26 minus 18. So at this point of time, I'm not changing any character. I'm not changing this either H or Z. I'm just simply finding the minimum character, minimum shift required to make both the characters equal. So this is simply 8. Cool. And I also have computed the cost of 0 comma A comma character A. 0 comma 0, this simply means for character A, what is the minimum operation we required to convert s of 0 and s of 2 to character A. So this was simply equals to how many operation? So this was simply equals to 10. Because first I will convert this, the sky value of H is 7. The sky value of H is 7. Cool. So this is simply equals to how much? This is simply equals to 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10 or light. So let me just quickly check how many operations do we require. Okay, so let's say we require 10 operation. So then here after I'm checking whether dp of whether dp of 0, dp of I, dp of I, I'm checking for dp of I minus cost of I and a. That is it possible to convert this convert this into a? So yes, it is possible because this value is less than k. The new updated value of k is equals to was equals to 2. The new updated value of k was equals to 10, is equals to 2. And this difference, so here we must have at here cost of 0 comma a minus dp of I, and this value is this value is equals to less than or equals to k, and yes, it is equal less than or equals to k. So I will just simply convert this h and z both to character a, and now my k will simply reduce by this difference. And what is this difference? It is simply equals to 10 minus 8, which is equals to 2. So now my k will simply reduce by 2, and now the value of k has changed to 0. So and I will convert this into a. So this is the complete approach. And if there is any doubt, then it must be clear after discussing this implementation. So here is my length of the string. Then this is my cost matrix of size n plus 1 divided by 2 multiplied by 26. Then this is my dp array. Then iterate while I is less than or equals to j. And here I have initialized I with 0 and j with n minus 1. You can also use the idea I and n minus 1 minus I. Both are the same thing. So I have initialized this dp of I value with some large integer. Here in this case it is 10 power 9 plus 7. Then this is the correct character current, which is not required. Then I iterate over all the 26 character, and cost of IC, cost of converting character S of I and character S of J, both. Cost of converting S of I and S of J into character C. How many operations we require? So it is simply equals to f of S of I, comma, this thing, and plus cost of converting this character S of Z into C. So then I will simply add these values. And here we have a function f. So function f, where where I am returning the minimum cost to make a and b both equal. So if the sky value of a is greater than the sky value of b, then this simply swap a and b. Here I am assuming that b has sky value greater than a. So then this is my value of d1 b minus a, and the value of d2, it is simply equals to 26 minus b minus a. We have already discussed this thing, and whichever is minimum, I will return that value, minimum number of shift required to make both a and b equal. And this value I will store in cost of I, comma c. But there is an edge case. If I is equals to z, then this will mean you are at the middle index, and the length of the string is odd. So the middle index has not been mapped with any character. It is individual character. So that's why I divide this cost of I, comma c by 2. Because in this case, f of I is equals to f of j, right? So it simply means the cost of converting the same. I have added this cost twice because both are same. So that's why I have divided it by 2. Then minimum value of dp of I. And then I will just simply subtract dp of I from k, and I plus plus and j minus 1 take me to the next pair. And if the value of k is less than 0, then it won't be possible to convert it into a palindrome. So simply return empty string. Now I know I can convert it into a palindrome. Now the next thing, I have to find the smallest palindrome. It's lexicographically smallest. So again, initialize I is equals to 0 and j is equals to n minus 1. Then the same logic, while I is less than or equals to j, then I iterate over all the characters, and here this is the effective cost. This is the shift that minimum I required, and this is the cost for converting I and S of I and J both to character C. And if this difference is less than or equals to K, then I can. So I will just simply subtract this difference from K and convert S of I and S of J both to character C. Cool. And then I will just simply break this loop because we are looking for the smallest one. And I have started from the character A to Z. And then I plus plus and J minus minus. So yeah, this was the complete solution. Is it clear to everyone? Just write a quick plus one so that we can discuss the last problem and wrap the session. The last problem was also very interesting. Okay, can you give the code in sub ID? Okay, so what you can do, you can follow me on GitHub. GitHub. I will update my repository with all the four problems solution. So yeah, this is my GitHub account. Just go with this URL, and here the username is Ayush 8303, and I will update all the four problem solution and create one new repository. So make sure to okay after half an hour. So shall we move to the next problem, the last one? So after half an hour you can find the solution over the repository. I will create one new repository with the contest analysis name, and you can search everything over there. So minimum maximum product graph. So this is a fairly interesting problem and uses some very advanced topics of math. Not very much advanced, but at least for the beginner for beginners, this might be the hard problem, a very hard problem. So you have a given a complete graph of n node, and you need to find the maximum number of edges, let's say x, that can be removed from the graph such that the product of sizes of the resulting component is maximum. And also you need to find the minimum number of edges, let's say y, that can be removed from the graph such that the product of sizes of the resulting component is maximum. And you need to return the value of x minus y. So a very straightforward question. You need to find two things. The very first thing, the product of size, the product of the sizes of the remaining component must be maximum in both the cases. In both the cases, the product of the remaining components, sizes of the remaining component must be maximum. And you need to find this maximum product by removing maximum number of edges. And let's say this is x, and you need to find this maximum product by removing minimum number of edges. Let's say this is y, and you need to return x minus y. So let me explain you the first sample test case. N is equals to 3. What will be the output? So n is equals to 3. So this simply means a complete graph of a 3 node. So the graph is complete. What does the term complete mean? So this simply means that there is a direct connection from one node to any other node. All the nodes are directly connected with each other. So this is the definition of a complete graph. And in complete graph, the number of edges is simply equals to n multiplied by n minus 1 and divided by 2. These are the number of edges in a complete graph. And you can also visualize this formula very easily, that we have n number of node and every node has n minus 1 edges, because for every node we have n minus 1 other node. And since we have counted some edges twice, so that's why we have counted all the edges twice, so that's why I have divided it by 2. So the complete graph has exactly these many edges. So for n is equals to 3, let's say this is one node, this is a second node, and let's say this is the third node. So this is a complete graph. Every node is connected with every other node. Now what is the maximum product of component sizes? So the maximum product here is 3. Here the maximum product is 3. And what are the possible ways to achieve this 3? First, I need to tell the minimum number of edges that I can remove to have the product of remaining components as 3, and also I need to find the maximum number of edges. So this maximum number of edges that has to be removed is equals to x, and here in this case the maximum number of edges that you can remove to get the product as 3 is 1. If you remove this 1 edge, then the product is 3, but you cannot remove this 2, because if you remove the 2 edges, now you have 2 components and their product is simply equals to 2, which is not maximum. The maximum here in this case is 3. So to get 3, you cannot remove more than 1 edges. So the value of x is equals to 1. And what is the value of y? That is the minimum edges that we can remove to get the maximum product. So the minimum edges that you can remove to get the product 3 is 0. Do not remove any edge. And if you do not remove any edge, then the component is having size 3, which is your maximum product. So here in this case, my answer is equals to 1 minus x minus y. X minus y, which is equals to 1 minus 0, which is equals to 1. So that's why here in this case, the expected output was 1. So I hope the problem statement is at least clear to everyone. Now, please try to pay more attention and listen to me very carefully. So the very first thing, we have n, and how I will divide this n to get the maximum product. So in the first step, I will find what is the maximum product that we can have from a graph with n node. So this simply means I have to break this n into some chunk to get the maximum product. So let's just for a simplicity, I have decided to break this into a 2 chunk to get the maximum product. So which is an optimal path? So n, let's say it is equals to 10. So let me just draw the number line. So do not get confused. Here I have decided to break this n into 2 components. So this is 1. Let's call this as 2. Then 3. Then 4, 5, 6, 7, 8, 9, and let's call this as 10. So what are the possibilities we have? So either we make one component, either we make one component with the size 1 and another component with the size 9. So what will be their product? If you break this graph of n node into 2 component 1 and 9, then their product is simply equals to 9. And what if I break this into a 2 component of size 2 and 8? So in this case the product is 16. What if I break this into 2 component with the size 3 and 7, with the size 3 and 7? So in this case In this case, the product is 21. 21. 3 into 7. And for 4 and 6, the product is 24. And for 5 and 5, if I break this 10 into two parts, 5 plus 5, then it is 25. Then this is 25. And now here you can see the 25 is the maximum product that we can make. And this is the idea. It is always optimal. Now please try to pay more and more attention. It is always optimal to to break this n into chunks of same value, which is 5 comma 5. And now you might wondering that we can also break this into 5 chunks of 2. 5 chunks of 2. So yes, but the idea here is to break the n into a chunks of same component, same value, chunks of same values. And you can also prove this thing mathematically with the help of geometric mean and arithmetic mean. So let's say I have two integers a and b. I have two integers a and b. So what will be their geometric mean? So their geometric mean, or you can simply say it is you can simply say mean. So just for a simplicity, let's say a plus b, and this is equals to n. I have a break this n into a two components. This a graph with n nodes into two component. One component with a number of node and another component with a b number of node. So here, what will be their arithmetic mean? So this is a plus b and divided by 2. I'm finding the average. Arithmetic means average. Arithmetic mean. And what will be their geometric mean? So their geometric mean simply equals to average of their geometric progression. So a into b and a into b, and then you have to take a power with 1 divided by the number of items that you have, which is 2. So 1 divided by 2. So this is nothing but the square root. So square root a multiplied by b. Cool. And this square root is always less than or equals to this arithmetic mean. This is a very standard mathematics inequality. So let me just quickly search it here. So arithmetic mean and geometric mean inequality. So yeah, this is a very famous inequality. So in this way you can prove this mathematically. So here I can write in this way. It is this value is always less than or equals to this arithmetic mean. So in which case it can achieve the maximum value. So it maximum value when it is equals to this arithmetic mean. So in which case it is equals to arithmetic mean. So when a and b both are same, when a and b both are same, so if a is equals to b, then this is nothing but 2a. Here I have replaced b with a divided by 2, and this is simply equals to the square root of a square, and this is a, and less than or equals to a. So this is the only case when all the items has the same value. When all the item has the same value, in that case only you can achieve the maximum result. And what will be their maximum result? Their maximum result when arithmetic mean and geometric mean both are same. And you can also feel this thing with the help of this number line. But now I hope it is clear to everyone. Now some of you might wondering, and in case if there is some remainder, let's say if it was 11. So in this case, so the maximum result you will get 5 comma 6. In this way you will get the maximum result. If there is some remainder, then you can add this remainder to any item to get the maximum. Now some of you might wondering that which result will select, because this product is 25 but this one is 32. So which result I will select? This is the problem. So for this thing I'm going to use a derivatives. and differentiation. So I'm not considering the case of remainder. We'll discuss how we'll manage the remainder very soon. But there are multiple possibilities. Let's say I have 12. Let's say I have 12. So one thing that is clear to me, I have to divide this into a chunks of same values. So what are the possibilities? I can either divide it into a six chunks of two, or I can also divide it into four chunks of three. These are the four components. Each component has size 3. Or I can divide it into three components of a size 4. Or we have a 6 comma 6. Multiple options I have. Multiple options I have. But which one is better? Which one is best? So now I'm going to discuss this thing. Which one is best? So let's say x x will give me the maximum product. So what will be the product? So the product is simply equals to x to the power n divided by x. Because let's say you have a 12. Let's say you have a 12. So if you divide this 12, let's say the value of x is equals to 3. So in this case, what will be the product of all the component? So this is nothing but 3 multiplied by 3 multiplied by 3 multiplied by 3, which is equals to 3 to the power n divided by 3. So which is a 12 divided by 3, or I can say 3 to the power 4. This is same as x to the power n divided by x. So I hope this thing is clear to everyone. And to get the maximum, to get the local maximum, we all know I have to take a derivative. I have to take a differentiation with x. So d by dx. I need to find d by dx such that d by dx is equals to 0 to get the maximum value of this equation. Cool. So let's call this x to the power n divided by x as a, and divided by x as a. So what I need to find, I can just simply reduce this into this way. dA by dx is equals to 0. dA by dx, this must be equals to 0. Cool. So let's just quickly solve for this equation. So first I will take a log with the base e on both hand side. So this just simply becomes n by x, and log of x base e, and this is log of a base e. So this can also be written in this way. So now here I have to take the derivative. So here first I have taken the log. Now I have to differentiate this thing. So differentiate d by dx, and I also need to differentiate this one also. So this thing, that is d by dx, and log of a base e. So there was a very famous formula that we have learned in our differentiation. That is the differentiation of u v dash. It is simply equals to u dash v. First I will make this v as a constant, and then I will make this u as a constant. Then I will make this u as a constant. So u dash v and v dash u. Cool. So in this case, first I have to make this log of e base x as a constant. So this is my u, this is my u, and this is my v, u and v, u and v. So I know this x is constant, this n is a constant, right? And the differentiation of x, the differentiation of d by dx of 1 by x d by dx and 1 by x, its a differentiation is equals to minus 1 by x square. I will have to move this x to the backward, and then I have to subtract basically this its power will come to the front, and it has to be subtracted by 1, and then I have to make this bottom. So okay, so let me just explain you here. So d and x and dx, so its power is minus 1, right? So now I have to move this exponent, this power to the front. So this is simply equals to minus minus x and 1 minus 1, which is equals to minus 2, which is nothing but 1 by x square. Cool. So then here in this case, it is simply equals to n and multiplied by 1 by x square, and then this constant term. Here I have taken this as a constant. So this is nothing but the log of x base e. And then now I have to differentiate this y. So this is n by x as a constant, and the differentiation of log of e base x, which is simply equals to 1 by x. So multiplied by 1 by x, and this is simply equals to 1 divided by a, and then dA by dx. Do not get confused. This a was not a constant, right? So that's why we have this dA by dx, and I need to find the value of dA by dx, same as this one, same as this one. So now let's just take x square as common. So if I take x square as common, so n x square, and also let me just multiply this a over here. But okay, do not. So yeah, so x and then here plus 1. Cool. Just I have simply taken x square common, and this is simply equals to 1 by a and dA by dx, dA by dx. Now if I multiply this a, I can multiply this a on a left hand side. So now na and divided by x square, and it is simply equals to dA by dx. And we all know, to get the maximum value, we must have dA by dx is equals to 0. So this term is equals to 0. This term is equals to 0. So to make this equals to 0, the value of n was constant. The value of n was always greater than 0. It won't be possible to have the value of n is equals to 0, because in this case your product is equals to 0. It is not possible to break it further. And the value of x also cannot be equals to 0, because if it is equals to 0, then this term, it's turned out to be infinite, so not equals to 0. And a is also constant, and its value is simply equals to its value is simply equals to this thing, this expression. So for me, it won't be possible to make this, to say that this value is equals to x. This is not possible. This value is not equals to 0, never equals to 0. Now we are left with only one possibility, which is this one. So minus log of x base e plus 1 is equals to 0. So I can just simply say log of x base e is equals to 1, is equals to 1. Then what does it mean? So what does it mean? Whenever I say log of 8 base 2 is equals to 3, so it simply means that 2 power 3 is equals to 8. Cool. So here, can I say this thing? The value of x, it is simply equals to e to the power 1. So the value of x is simply equals to e to the power 1, or I can say the value of x is equals to e. So this is the value of x. And what is the value of e? So in mathematics, the value of e is greater than or equals to 2 and less than 3. So the value of e. So the value of 3 is approximately 2.178, and so on. So the value of e is equals to 2.17718, and so on. So I have to pick this x as an integer, right? Because it is not possible to select some decimal number and subtract a decimal number of components from n. So this a must be integer. And what is the value of x? This x must be integer. So this x must be either 2 or 3, whichever will give the best result, because the value of e is less greater than 2 but less than 3. So I have to either select 2 or either select 3. These two possibilities only I have. So which one I will select? Now I can simply brute force. I can simply apply brute force, and whichever is maximum, I will select that one. So let's say the value of n is equals to 6. The value of n is equals to 6. So either you can break into three components. You can break into three components of size 2, or you break into two component of size 3. So if you break into 3 component of size 2, then their product is simply equals to 8. And if you break into 2 component of size 3, then their product is equals to 9. So with this thing, now I know it's always optimal to break n into chunks of 3, into chunks of 3. So I hope this thing is clear to you. So this will give you the best result every time this will give you the best result. And here is the proof. This differentiation is the proof for this. So if there was something which was not clear to you, then make sure to rewatch this video, and once the session is over. So it's always better to break this n into a chunks of 3. So 3, 3, 3, 3, and then we are left with some remainder. So now what I have to do with the remainder? So what is the remainder we have? So the remainder is n mod 3. This is the remainder, and this remainder could be either 0, 1, or 2. So if it was equals to 0, so if it was equals to 0, then we can't do anything, because n is completely divisible by 3. What if is equals to 1? So what if remainder is equals to 1? So n, this n can be breaken down. Let's say we have a 3. Let's say we have a 4 chunk of 3, and then after we are left with some remainder, and this remainder 1. So to get the maximum product, if you just simply put this a component of size 1 here, then your product won't be changed. Your product will remain as it is. So it's better to increment the size of some component. It's better to increment the size of some component and make it equals to 4. Make it is equals to 4. Cool. But what if remainder is equals to 2? So in case a remainder is equals to 2, and I know I have divided this n into 4 chunks so far. So this is a 3, 3, 3, and 3. So in this case, where I will adjust this 2. So now I have two options. I have two options. The very first option. Now some of you might wondering that I will increment the value by 2, one component value by 2. Now it is equals to 5. But this will not give you the best result. The best result is to add this component. So 3 multiplied by 3 multiplied by 3 multiplied by 3, and then add this component separately of size 2. Now this is the best result, and this best result can also achieve with this path: 3 multiplied by 3 multiplied by 4 and multiplied by 4. Or maybe it was not best. Yeah, it is not best, not the best solution. But here I want to discuss this thing. So yeah, this is the maximum product that you can achieve. Just simply add this component here. Just simply add this component. But for this, we have another path. This can also be written as 3, 3, 3. That is, I'm not going to change. I'm not going to change two components. Previously, we have 4 components, and I'm not going to change a 2 component. I'm only going to change 2 component, because I know I'm left with the remainder 1. I'm left with the remainder 1. So what I will do, I will just simply make it equals to 4, 4 to get the maximum result. Or do not get confused with this thing. I will just simply make it equals to how much? 3 multiplied by 3 multiplied by 3. So first thing, I can just simply change this 3 to 4. Or the next thing that I have, I just simply add 2 components of size 2 2. Yeah, both of these path will give you the same result, the maximum product. Cool. And now let's just quickly discuss how to solve the entire problem. I hope this thing is clear to everyone, and make sure to remember this formula, remember this idea. If you want to divide the n into a different chunk such that their product is maximum, so always keep on dividing it into a chunks of 3. This is the best idea. Now after getting this approved, Now how we can solve this problem? So I know my answer is simply equals to maximum edge removed. Maximum edge removed to get the maximum product, and minus minimum edge removed. Minimum edge removed to get the maximum product. And we all know this is x, and this is y. So x minus y was my answer. So can I write in this way? That is maximum edge removed is simply equals to total edge minus, now please try to pay more attention, minus minimum number of edges, minimum edge in remaining graph, remaining graph, remaining graph, minimum edge in remaining graph. This is the value of x, because if you now if after removing the edges you have a minimum number of edges, then this simply means you have removed the maximum number of edges. A very straightforward idea. And this can also be written as total edges minus maximum number of edges in the remaining graph. Because if you have now the maximum number of edges, then this simply means you have removed the minimum number of edges. A very straightforward idea. So this can be written as this plus total edge and minus total edge will get cancelled out, and my answer is simply equals to minimum edge in remaining graph, minus maximum edge in remaining graph. This is my answer. Maximum edge in a remaining graph. Now let's just find the minimum edge and maximum edge in a remaining graph. So how to find this a minimum edge? So we all know I have divided this n into a chunks of 3. I have divided this n into a chunks of 3. So that is some chunks of 3, and if I was left with some remainder, let's say the remainder that I was left with is 1. So in that case I need to find the maximum. So in that case I have two possible paths. Either I add this remainder in one component, or make a two component of size 2. So 3 comma 3 comma 3 comma 4. This is one possible way. Or another possible way, 3 comma 3 comma 3 comma 3, and then 2 comma 2. So which one has the minimum number of edges? Which one has the minimum number of edges? If these are the component of your final graph, and so how many minimum number of edges we require? So if we have 3 node, if I have 3 node, let's say if I have 3 node, and this is a complete graph, right? So to keep these 3 nodes connected, what is the minimum number of edges we require? It is simply equals to 2. It is simply equals to 2. So for this my answer is simply equals to my answer is simply equals to 2 plus 2 and plus 2. Cool. And then I have two components of size 1 of size 2, two components of size 2. So in this case my answer is simply equals to 2 plus 2 plus 2, and to get connected with the to connected two nodes, a component of size 2, we required minimum 1 edge. So plus 1 and plus 1, right? And here in this case it is simply equals to 2 plus 2 plus 2, and we have 4, right? So let's say we have 4 node. So to keep these 4 node connected, we must have 3 edges. So plus 3. So now you can see when I have to maximize the if I have to minimize the edges in the remaining graph, then I will just simply follow this path. I will simply follow this path, because here I am adding 1 plus 1, right? But here I am adding 3. So do not make a component of size 4. Instead make a component, two components of size 2, because we need to minimize the edges, right? So that's why 1 plus 1, not 3. So in this case, your answer is simply equals to, your answer is simply equals to, in this case, your answer is simply equals to number of components of size 3. So let's say count 3, number of components of size 3, and multiply it by 2, because every component of size 3 required 2 edges, right? And plus number of components of size 2 and multiply it by 1. So this simply count of 2 and multiply it by 1, because every component of size 2 required 1 edge, and we all know how to shift the remainder. Now in this case, what will be my answer to get the maximum edge in the remaining graph? So I know I have broken this n into a chunks of 3. So chunks of 3. Now in this case, let's say the remainder is equals to 1. So the remainder, if the remainder is equals to 1 and I need to find the maximum number of edges in the remaining graph, then we must have to follow the above path. We must have to follow this path. That is 3, 3, 3, and then just simply add this one remainder here. Do not convert it into a 2 comma 2, because this will not work. Select 4. When you select 4, you will get the maximum result. Cool. So let's just go with this 4. Four this 4 wala path. So in this case, what will be my answer? So in this case, and there might be the case when your remainder is equals to 2. So if remainder was equals to 2, then we must have followed this path 3, 3, 3, and add 2. Here we do not have 2 path. We must have to add a component of size 2. So so no possibility. We must have to select this path. So my answer is simply equals to, for this case my answer is simply equals to count of 3, the number of component of size 3, and multiplied by 2, plus count of uh, count of 2 and multiplied by 1, as we have already discussed. And it is not possible to have 4 and 3 both. It is not possible to have 4 and 3 both, but just for a simplicity purpose, I'm going to also write for 4. So count of 4, the number of component of size 4, which is obviously not be greater than 1. And how many maximum edge we required. So the very first thing, I need to change these values. So let's say I have a component of size 3. So component of size 3, so it requires maximum 3 edge, right, to get connected. We need to find the maximum. So every component is a complete component, right, complete graph. Now for 2 I need only 2. Then what for 4? What is for 4? So for 4 I required 6 edges. This is the complete graph for 4 component with a size 4. So then it must be multiplied by 6. And yeah, this is the complete solution. Let me just again quickly summarize it. So it's always optimal to divide n into a chunks of 3, and if there is some remainder, then we have to adjust the remainder. So if the remainder is 2, then we must have to add a new component with a size 2. And if the remainder is 1, then I have two possible paths. Either I convert this one component into 4, or a two components of size 2. So which one will give the, both will give you the same result. Both will give you the same result. So which one I will follow? It's depend on the edge cases, what we require. So my answer is simply equals to maximum edge removed in the remaining graph minus minimum edge removed in the remaining graph. So I can also write this maximum edge removed is equals to total number of edges in the graph and minus minimum edge in the remaining graph. So in this way, I get the maximum edge that I have removed, and I can simply convert this minimum edge removed as total edges in the graph minus maximum edges in the remaining graph, so that I get the minimum number of edges that I have removed. So my answer is simply equals to this thing. My answer is simply equals to this thing. Cool. And now for every component, I need to find the minimum number of edges. So assume this as a tree-like structure. So here for remainder one, I have two possibility. This one, I have two possibility. This one or this one. So which one I will follow? Definitely, I will follow this one because I need to minimize the number of edges. I need to minimize the number of edges, right? And for maximum, I will follow this path. I will follow this path. So I need to maximize the number of edges. So this is the complete solution. Let me just show you the implementation. So yeah, this is the method that you need to complete for a given n. So if n is equals to n is less than or equals to 2, then return 0. Okay, let me just quickly check. The value of n can be up to 18, right? So in this case, if n is less than or equals to 2, then the answer is always 0, the value of x minus y, because the maximum product that you can achieve is 2 and there is only one edge. Cool. So this is my mod, and this is my value of x, that is a maximum number of maximum remaining edges, and this is minimum remaining edges, right? So x minus y will be my answer. So this was my y, and this is my x. So because here this minus 1 will get converted to a plus, this minus will get converted to a plus when I will open the bracket. So this is nothing but y minus x, and again take a mod with this one. So here I am having the function maximum remaining edges, maximum number of edges that we have in the remaining graph. So four size component, I have initialized four size component with 0, then two size component with 0, and the three size component is simply equals to n by 3, and the remainder is n mod 3, and if the remainder is 1, then I know I need to find the maximum, right? So I will convert it into a four size component, and a three size component is decreased by 1, and if the remainder is 2, then the two size component is increased by 1, and my answer is simply equals to maximum number of edges that we required for two size component. This is simply equals to, this is simply a formula of complete graph, n multiplied by n minus 1 divided by 2, and minimum edge that you required is a tree like structure, so this is simply n minus 1. And yeah, in this way I will find the answer, and finally I'm returning this answer. Then similarly for the minimum remaining edges, I need to only make the changes for the remainder, because n by 3 is fixed, the product is fixed. So if the remainder is 1, then I must have to decrease the component of size 3 by 1, because I am going to convert a component to component of size 2. So that's why two component of size 2, and if the remainder is 2, then I must have to convert it into one new component. So my answer is simply equals to this thing, minimum number of edges required for component of size 3 and multiplied by that count, and similarly for 2. So the time complexity is constant. So in this way you can solve this problem, and you can find all the solution after half an hour on my GitHub repository. So yeah, this was all from my end. In case if you are having any doubt, then just go ahead, otherwise we can wrap the session. So I hope you have enjoyed the session and have learned something new. If there was something which was not clear to you, so I would highly suggest just go with the recording part, and I tried my best. And if in case if you have learned something new, then please hit the like button and also write your comments so that I can improve these sessions in the future. So thank you so much everyone for joining this session, and have a good day.